How do we graph y equals a sine of x and y equals a cosine of x? Well, the reason we chose the letter A for that, A stands for amplitude. The absolute value of A is called your amplitude, which means how high does that function go up and down? How high? Oh, Catherine, you in? So right now, I'm going to go back and just do the basic function. Just the basic function. What does the sine of x looks like? What's the cosine of x looks like? So if I was to graph sine of x, the only way I know how to graph it, like if you've never seen it before, we can always go back to the basic, and the basic is always what? Pick values. You go x and sine of x. So this is x, and this is sine of x. And I'm going to graph it in terms of degrees first, then I'll do it with radian. Try to make it nice and neat. I need more than that, but I'm just giving you some values. So if I use the 0, if x is 0, I'll take sine of 0. What is sine of 0? It's 1. If x is 30 degrees, I'll go by 30 degrees. Sine of 30. On your calculator, that's 0.5. Just take your calculator and push the button. If x is 60 degrees, sine of 60 is what? 0.87. If it's 90 degrees, sine of 90, which is what? 1. If it's 120, I'm going by 30. 120, it's 0.87. If it's 150, it's 0.5. If it's 180, that's a 0. If it's 210, that's negative 0.5. If it's 240, that's negative 0.87. If it's 270, that's a negative 1. And you continue with that. Keep going. Well, if you keep going with it, what you're going to see, I'm going to draw two pictures for the sine of x. One with degrees, one with radian. I'm going to draw them. Because when we deal with trig, a lot of times we're dealing with radian, not degrees. And you start picking the points when x is 0. Sine of 0 is 0, not 1. I don't know why I said 1. When it's 30 degrees, sine of 30 is 0.5. When it's 60 degrees, 0.87. When it's 90 degrees, 0.1. When it's 120, 0.87. 150, 0.5, 180, 0. So you're going to find out the graph looks like this. And it repeats itself. It takes 360 degrees to repeat itself. That's known as one full period. And it doesn't stop there. If I picked values beyond the 360, you'll see that function continues. And if I pick negative values, you'll see it continues. It never stops. the highest value the sine reaches is the 1. The lowest value the sine reaches, -1. Unless that A is different. You'll see what that A is going to do. If you want to graph it in radian, so this is really 360. This is the 180 degrees. This is the 90, the peak is the 90 degrees, and the lowest value is the 270. If I graph that in radian, again, this is 2 pi, this is pi, 180 is pi, this is pi over 2, and this is 3 pi over 2. Again, it repeats itself there again and again and again. And the y value, that's your range, goes from -1 all the way to 1. I mean, I have them backward here. From -1 all the way to 1. That's what the range looks like. If somehow you can store this picture in your head, in your mind, it's going to make the next 3 sections much, much easier. So I'm going to use degrees and radians. I'll mix and match, but again, 9 out of 10 times when we're dealing with trig, we use radian. But most of us, we don't use radian that often in our daily life, so we're not familiar with it. We know degrees, but not radians. So you'll see me mix and match. So let me put the sine and put the cosine on top of each other and show you the difference between them. And again, I'm going to try to store them in my brain there, so I never have to redraw them by picking points. I don't want to do that. It's time consuming. So the sine of x, if I do just one full cycle, it will look like this. This is the 2 pi. If you keep writing these numbers here, by the time you leave today, you'll memorize them. You'll know what they are. Again, the height, the peak is 1. The lowest point is -1. The sine is between them. And it repeats itself. I'm only interested in one cycle. That's called one cycle. One full cycle. Then it repeats itself. Now the cosine, so this is sine of x. The cosine very similar to that, except it looks like somebody dragged it backward. If you pull this shape, this picture backward till the peak hits this line, pull it back, which is 90 degrees. If you pull it back 90 degrees, starts from here, and it goes like this. Again, it takes 2 pi to complete its full cycle. It goes the same height. It has to go the same height. The peak value is 1, the lowest value is -1. If this is the 2 pi, then this is pi. This is pi over 2. This is 3 pi over 2. Again, it repeats itself. So to me, it looks like all I did really put my x-axis and my y-axis right here. If I put my y-axis right here, I have the cosine function. A lot of times you hear me say, it looks like the Karate Kid. Do you remember the Karate Kid when he was standing on one foot there, his hands up in the air? So that's the peak. It comes down and it goes back up there. That's why I call it the Karate Kid. So that's the graph of a cosine function. The graph is periodic, means it repeats itself. The domain, the x value goes from 0 to 2 pi, but then it repeats after that. Every 2 pi it repeats. That's the period. The period is 2 pi. But the domain really goes all the way from negative infinity to infinity. But for one cycle, if you're looking for one cycle, is 0 to 2 pi. That's your period. So your period is how long it takes it to repeat one full cycle. We'll get to that when we get to section 2. We'll talk about a period. That's a 2 pi. The range is from -1 to 1. There's not a single value where the function is undefined. So technically, when I say what's the domain, all real numbers. Because any x value, you will have a y value, either cosine or sine. So the domain, that's the x value, all real numbers. And what's the range? Where's the y value? From where to where? What's the smallest y value that you see there? -1. What's the largest one? 1. Again, it's periodic, meaning it repeats itself. The maximum value is 1, the minimum value is -1. So now what happens if that number in front is not a 1, like this example, the value is 1 and 1? What happens if the value is 5 or 2 or 2/3? That's your amplitude. So let's go back to that section. What does the 1 do? So if you have y equals a sine of x, or y equals a cosine of x. As I said earlier, a is the amplitude. Amplitude is the absolute value of a. What does that mean? That means your maximum value will equal to a, and your minimum value will be what? It'll be negative a. You're stuck between a and minus a. And if a is greater than 0, or greater than 1, I'm sorry, let's do the absolute value of a. If the absolute value of a is greater than 1, like a 2, a 3, a 4, what did you do to that graph? You stretch that graph. That's called vertical stretching. You made it taller. And if the absolute value of a is less than 1, you didn't stretch it. What'd you do? Compress. Yep, shrink it. You compress the graph. Our book doesn't talk about stretching and compressing here, but that's okay. I'm just giving you a little info about them. So let's take an example and see what will happen. Let's say I come in and says, can you graph y equals, here's my question, graph y equals 3 sine of x. What is my amplitude? My amplitude is the absolute value of 3, which is what? 3. Here's the basic sine function. I said if you just remember that picture, this is what sine of x looks like over one full period. Here's the 2 pi. Here's the pi. Here's the pi over 2. Here's the 3 pi over 2. This is sine of x. Just the basic sine function. It goes as high as 1, as low as what? Negative 1. What do you think 3 sine of x will look like? Take that and stretch it as high as what? 3. So the graph will look like this. Still goes through the same points. So this is 3 sine of x. It goes as high as what? 3. As low as what? Negative 3. The same shape. We just stretch it. Again, if you understand what the sine or memorize what the sine of x looks like, you can graph any of these. Let's say I want to graph y equals 1/2 cosine x. 1/2. What's my amplitude? Equals the absolute value of 1/2, which is 1/2. So here's my picture. I'm going to do the cosine first. Remember, the cosine function looks like the Karate Kid, that movie there. Starts from, I'll start from 1. This is the 1 here. I'll make it bigger. Negative 1. This is one cycle of it. Starts at 1. It goes to negative 1. If you want to put the rest of it, go ahead. I don't need the rest of it. I'm only interested in one cycle. This is the 2 pi. This is the pi. Pi over 2, 3 pi over 2. This is cosine of x. The blue line's cosine of x. I want to graph 1/2 of that. So every value is going to be a half of what it used to be. When it used to be 1 becomes what? 1/2. Right there. When it's 0, what's 1/2 of 0? Still 0. When it's negative 1 here, what's 1/2 of negative 1? Negative 1/2. Half of 0 is still 0. Half of 1 is back to half. So this is 1/2 cosine of x. It goes as high as 1/2, as low as negative 1/2. As I said, that's the only thing the number on the front does. The only problem I have to be careful with that when that value in the front is negative. Okay, I'll move into the next one. And I'll give you a negative value. I'm waiting here. The camera's dead, so they keep telling me never leave the camera dead there. Negative 2 sine of x. Negative. My amplitude, what's my amplitude? It's the absolute value of negative 2, still 2. Amplitude will never be negative. It's a sine function again, the basic sine function, the graph, here we go. That's the sine of x. There's the 2 pi, pi over 2, 3 pi over 2. As high as 1, negative 1. We know what the 2 does. The 2 makes it what? Twice as high. But what's the minus sign is going to do? It's going to flip it. The plus becomes the minus becomes a plus. Basically what you're doing, you're multiplying each value by negative 2. When it's 0, what's negative 2 times 0? 0. When it's 1 here, what's negative 2 times 1? Negative 2, that's down here. When it's 0 here, what's negative 2 times 0? 0. Here is negative 1. What's negative 2 times negative 1? Plus 2. So the minus sign flips the graph. The plus becomes minus, the minus becomes a plus. That's called reflection. That's what the graph will look like. So where it used to be plus, now it's minus. Where it used to be minus, now it's a plus. This is negative 2 sine of x. Again, I'll do one more and we're done with section 1. And that's knowing what the amplitude does. Graph y equals negative 3 cosine x. So this is cosine of x. Cosine of x starts with 1 high here, and it goes down to negative 1. This is the 2 pi, pi over 2, 3 pi over 2. High is 1, negative 1. This is cosine x. My amplitude for this is going to be what? It's the absolute value of negative 3, which is 3. So instead of starting with 1, what are we going to start with? If that was plus 3, you'll start at 3. But because the minus sign is going to flip it. So you're going to start from negative 3 and go as high as 3. So the graph should look like this. That's what the graph should look like. This is negative 3 cosine of x. It's upside down because of the minus sign and stretched by a value of 3.